Let's answer part A. That is, we have to write an expression for the approximate number of strands of bacteria. So, since the number of bacteria present is actually dependent on the time, we can utilize the population model, that is P of t, and this equals P naught e raised to the power of RT, R times of t. This P naught represents the initial population. This R represents the growth rate of the population, and T is the time. So basically we have to determine the values of P naught as well as the growth rate R using the given information. So let's use this information, that is after 1 hour the number of bacteria is 1000. So that is when T equal to 1. When we use this model, we say that the P of T, that is P of 1, equals the number of bacteria is 1000. And similarly after 4 hours, that is when T equals 4, which is represented as P of 4, the population is 3000. So using these two information, we are going to substitute into the model so that we can determine the values of P naught as well as R. So let's do that. Let me copy the model here, that is P of t. This equals P naught e raised to the power of RT. So first I'm going to plug in t equal to 1 into this model. So when I do that, I get P of 1. This equals P naught e raised to the power of R times of t, which is R times of 1. So this equals R times of 1 is R. So I can simply write down this as just R, e raised to the power of R. We already know that P of 1 equals 1000. So which means we can now replace this P of 1, that is the left side, equals 1000. So therefore this becomes 1000 equals P naught times of e raised to the power of R. Let's say that this equation is numbered. We say this equation number 1. Now using the second information, that is P of 4 equals 3000, which means when we plug in t equal to 4 into this model, we get P of 4. So therefore P of 4 equals P naught e raised to the power of R times of t. T is 4 here. So R times of 4 is 4R. I'm going to write down this as 4R. And we already know that P of 4 equals 3000. So which means we can replace this left side as 3000. So therefore this becomes 3000 equals P naught e raised to the power of 4R. And let's say that this equation is numbered as equation number 2. Now using these two equations, which involves P naught as plus R, we can determine the value of P naught as plus R. So for that, I'm going to do this. That is, I take this equation 2 and divide by equation 1. And this means we have to divide the left side by the left side of the equation 1, and the right sides has to be divided correspondingly. So in equation 2, the left side is 3000, and the left side in equation 1 is 1000. So we do like this, and similarly, the right sides we divide starting off equation 4. So I write down as P naught e raised to the power of 4R, and the right side expression in equation 1 is P naught e raised to the power of R. Now let's cancel this P naughts. These two gets cancelled, and 3000 divided by 1000 is 3. So let's rewrite this. This equals, that is 3 equals. Here we can do the subtraction of the powers, because according to the power rule, suppose if we have e raised to the power of m divided by e raised to the power of n, and this equals e raised to the power of m minus n. And similarly, if we have to find e power 4r divided by e power r, and this equals e power 4r minus r. 4r minus r is 3r. So this basically is e raised to the power of 3r. So I'm going to replace it over here. So this becomes e raised to the power of 3r. Now this is an equation involving just a variable r. So to solve this, which has an exponent in the right side, I'm going to take natural logarithm to both sides. So apply natural logarithm to both sides. And when I do that, I get natural logarithm of 3, and this equals natural logarithm of e raised to the power of 3r. Now we can use the power properties of natural logarithm, which means this 3r will come in front. So I'm going to write this as natural logarithm of 3 equals, we have 3r times of natural logarithm of e. We must be knowing that the value of natural logarithm of e equals 1. So therefore this quantity equal to 1. So 3r times of 1 equals 3r. So this means we can remove this, and just we have 3r on the right side. Now we solve for r from this equation by dividing by 3 on both sides. So therefore we get the expression for the growth rate r equals natural logarithm of 3 over 3. In fact, we can plug these values into the calculator, and when we do that, we get the approximate value of r, that is equal to 0.3662. So we determine the approximate value of r is equivalent to 0.3662. And now using this value of r, we can determine the value of p naught. For that, we can substitute this value of r either into the equation 1 or into the equation 2. I'm going to replace r into the equation number 1. So first let me copy the equation number 1. Equation number 1 is 1000 equals p naught e raised to the power of r. So let's replace this r as 0.3662. Now we can determine this value of p naught. So therefore p naught equals 1000 divided by e raised to the power of 0.3662. We can plug this into the calculator, and when we do that, we get the approximate value of p naught equals 693. This is rounded to whole number, so we say that the approximate value of p naught is 693. So now that we have determined this values of p naught as well as r, we can write the population model, that is an expression for the approximate number of strands of bacteria. So we can utilize this model. So I'm going to copy that and replace the values. We have the model as p of t. This equals p naught e raised to the power of r times of t. So let's replace the values of p naught as plus the growth rate r. So therefore this becomes p of t equals 693 times of e raised to the power of r is 0.3662 times of t. So this is the expression for the approximate number of strands of bacteria after t hours. And this answers question in part A. Now let's answer the question in part B. That is, we have to determine the approximate number of strands of bacteria originally in the culture. We already know this answer. That is, P naught is the one which represents the original population. So therefore, to answer part B, we say that the value of P naught, which is approximately 693. So the original number of bacteria or number of strands of bacteria, this is approximately 693. So we have answered both parts, the expression as well as the number of the original number of bacteria in the culture.